Good morning, class. We are looking at college algebra prerequisite. That's the prior knowledge that we need, and in essence, the support to move on. So we talked about fractions. Now we want to look at adding and subtracting fractions. In short, you can only add fractions if they have common denominators. If they don't, you can make up common denominators. For example, in this case, the common denominator would be the product of B and D. So this is raised and it becomes AD. This is raised and it becomes BC. So AD plus BC. And subtraction, remember, is a form of addition. So how do we add two rational expressions? First and foremost, we factor each denominator. This is clearly y times y minus 1. This one is a 2 times y squared minus 2, 1 plus 1. And this is y minus 1 squared. So this is complete factoring. And now you need to take a common denominator. As you can see, the common denominator would have y minus 1, 2. And then since this is y minus 1 squared, LCD would be 2y, y minus 1 squared. Y minus 1 squared covers this one. Now, we are going to raise each fraction such that this would be the denominator. So for example, this one, all you have to do, compare the denominator and you say, okay, 2 is missing and we need one more factor of y minus 1. That's what we multiply by the top and the bottom. And this one, in a matter of comparison, the one which is missing is y, so we're going to multiply the top and the bottom by. So I hope it's clear to everybody. So we keep the 2 out, y plus 2 times y minus 1, it's y squared, 2 and minus 1, they add up to plus y, and then minus 2. This is obviously 2y times y minus 1 squared. And this is 3y squared. Of course, we have the same denominator, and we are going to write 2, going to distribute 2y squared plus 2y minus 4. And then this one, minus 3y squared, and combine these two because they are like terms into negative y squared, and we repeat this the rest of it. Therefore, we end up with negative y squared, 2y minus 4 don't go anywhere, and the denominator remains. And that's the final answer. All right, so we're dealing with a complex fraction, and we want to simplify it. That's if they say simplify, or if they say perform the operation, that means the same thing. A complex fraction is a fraction within a fraction. As you can see, the top has two fractions, the bottom has two fractions, and you have different ways to approach this. The fastest and easiest way is to multiply the top and the bottom by LCD of all those four fractions, 1, 2, 3, 4. As you can see, a times a plus 1 will cover the two fractions at top, the same thing at the bottom. So let's multiply everything by those. This is the LCD for all those four fractions. So we're going to multiply this by each piece in the numerator as well as the denominator. So what happens? This one cancels out this one, and we get a squared. This one cancels out this one, and we get 1 times a plus 1, or simply a plus 1. This one cancels out this one, and we get the same thing, 1 times a plus 1. This cancels out this one, and we get a. So basically, you write the numerator as a squared plus a plus 1, and in the denominator, we can add these two to 2a. So the final answer is a squared plus a plus 1 over 2a plus 1. And because there is no common factor between the top and the bottom, we are done. I mentioned various exponential rules. And here's the negative exponent. A to the power of negative n is 1 over a to the power of n. So we are going to use that over here for this question. So 2 over 5, or 2/5 to the power of negative 3. So we are going to use this. Flip it over. 5 halves, that means the reciprocal, to the power of positive 3. So now 5 cubed, 125, 2 cubed, 8, and that's the final answer. Rational exponent. For all integers m, all positive integers n, and all real numbers a, for which a to the power of 1 over n is a real number. So the nth root of a equals a to the power of 1 over n. So this is the case. This means a to the power of 1 over n. Remember, when there is no exponent, that means the exponent is 1 for a. A to the power of m over n. That means a to the power of 1 over n to the power of m. Please understand the product of these two is m over n. So what happens here? It's the same as 125 to the power of 1/3 to the power of 2. And this is the cube root, which is 5. Square it, becomes 25. 27 to the power of 1/3 times 27 to the power of 5/3 divided by 27 cubed. We use the product rule first, and we add those two exponents. One-third and 5/3, they add up to 2. There are two ways to do that. If you want to go with the rules, you can say 27 to the power of 2 minus 3. Or 1 over 27. Or here's the second method, everybody. Right here, 27 squared over 27 cubed. This one cancels out the exponent and it becomes 1 over 27. In other words, 2 of this in the numerator, drop 2 of this in the denominator. In the denominator, 1 remains. So one of those 27s. Either way is fine. The fourth root of 16 is just 2, or you can write it as 16 to the power of 1/4. 16 is 2 to the power of 4. 4 times 4 becomes 1, and the answer is 2. However you want to look at that, the fourth root of 16 is number 2. What about the fifth root of negative 32? Notice that negative 32 is negative 2 to the power of 5. And this means 1/5, right? The product of these two is 1. So the answer is negative 2. A to the power of m over n is the nth root of a to the power of m, or the nth root of a to the power of m. It is easier to go with this format because if you raise it to the power of m first, it becomes larger and it becomes difficult to deal with. So for example, a to the power of 2/3, we are going to go with this. The denominator becomes the index. By the way, again, this is the index. So it's the third root of 8. And the numerator is the exponent. This, we should know, is 2. 2 squared is 4. Negative 32 to the power of 4/5. Again, this one, and the denominator, that means the fifth root of negative 32. And because we've already discussed this is 2 to the power of negative 2 to the power of 5. So this expression is negative 2, and to the power of 4 is positive 16. When you raise a negative number to the power of even, becomes positive because it's negative 2 times negative 2 4 times. However, negative 2 cubed is negative 8 because it's negative 2 times itself 3 times. So an odd exponent, okay? Evaluating the nth root of a to the power of n. If n is an even positive integer, the nth root of a to the power of n is absolute value of n. And if it's an odd positive integer, then it's the nth root of a to the power of n. Because class, if a is positive or negative, makes no difference to the power of even becomes positive. So that's why you want to be careful with that. So here's an example to make some sense out of this. P simply comes out as P, but P is a variable. We don't know if this variable is positive or negative, so we put it in an absolute value. What about 16? M to the power of 8 or to the power of 6? 16, remember the index missing means index 2. That is 4 squared. This is m to the power of 4 squared. This is r cubed squared. So we can write it this way, or notice you can do the factoring, prime factoring for the number. And ultimately, I'll quickly show you a second method in a moment. If you don't know anything about the variables, then you have to put this in an absolute value. If you know the variables are positive, then you have nothing to worry about. Now, notice this part, we can take it out because 4 is a number. The absolute value is 4. And m to the power of 4, regardless of the value of m, is always positive because we are raising it to the power of even. Okay? R cubed. Now, the second method is, of course, this one. The square root is 4. This one, you divide 8 by 2 and you get 4. 6 divided by 2 and you get 3. All right, now here's what we were discussing here. You can't drop the root because you can't say the index and the exponent are the same. You have to put it in absolute value and you get 2. Why is that? Because this is an even positive integer. And that's really the key, everybody. Now, it's important to understand the reason behind it. And it's because when you raise negative 2 to the power of 6, you get a positive number, 64. If you go with the order of operations, this number is 64, and it comes out as 2. Okay, that's why you have to put in an absolute value. However, if you have the fifth root of, let's say, negative 2 to the power of 5, it's just negative 2 because the index and the exponents are both odd. For all real numbers a and b and positive integers m and n for which the indicated roots are real numbers, here's the case. If you are multiplying it, you can put them under the same radical. The nth root of a, the nth root of b, the product is the nth root of a over b. the ratio is the same thing. You can go, by the way, from left to right or right to left. Needless to say, the denominator can never be 0. That's why b can't be 0. And if you're taking the root, and again you're taking a root, you can multiply the indices m by n and get a new index. Now, square root of 6 times square root of 54. You can put them together. You get 324, and you may know it's 18. The second method, and I want to show you that one because that makes it easier. 6 is 2 times 3. 54, 2 times 3 cubed, because it's 2 times 27, and that makes it 3 cubed. If you look at all of them, so you have, let's go with this, 2 squared 3 to the power of, okay? And then the answer will be, this comes out as 2. This comes out as 3 squared. Answer is 18. So prime factoring can make it nice and easy. What about this one? This has exponent 1. So we have cube root of m cubed. The answer is m. When the index is odd, you have nothing to worry about. The square root of 7 over 64, you cut it into 2 pieces. And you know that this comes out as 8. $175, you may see that as 25 times 7. 25 comes out as 5. Or you can factor 175. Is it divisible by 2? No. Is it because it doesn't end with an even number? Is it divisible by 3? 1 plus 7, 8 plus 5 is 13. No. So the next prime, remember prime numbers, they are divisible by themselves and 1 only. So 2, 3, 5, 7, 11, 13, 17, 19, 23, 29. So I hope everybody remembers them. So the next one would be 5. When we divide, we get 35. 5, we get 7. 7 gives us 1. So we can say it's 5 squared times 7. 5 squared comes out. So prime factoring can help, but this is another way of doing it. I want to show you how they do that, and I want to show you an easy way out for a question like this. 81, we're looking at cube root, is 27 times 3. This is x cubed times x squared. This is y to the power of 6 times y, and this remains as e to the power of 6. Now, this one is a perfect cube, comes out. This one is a perfect cube. This one is the same thing. This one is the same thing. So we can rewrite it in this fashion. So put the 27 with x cubed and y to the power of 6 and z to the power of 6 together. This comes out as 3 because it's 3 cubed. This comes out as x. This y squared. This is z squared, and this one remains. And that's absolutely fine. Okay. Here's the second method. Just change this to 3 to the power of. Remember, the index is 3. So you are going to divide the exponent 4 by 3 and say the answer is 1 with the remainder 1. You keep 3 to the power of 1 outside, 3 to the power of 1 inside. The next exponent is 5. Divide by 3. The answer is 1 with the remainder 2. You get 1 out, 2 in. The next one is 7. 7 divided by 3 is 2 with the remainder 1. So 2 out and 1 in. Finally, 6 divided by 3 is 2, and it comes out. The point being, this could be a faster way of approaching it. Add or subtract as indicated. Assume all variables represent positive. So don't worry about negative, positive real numbers. So in order to add roots, they must be identical. So something times square root of 2. As you can see, it's 7 times square root of 2. So 18 is the product of 9 and 2, and 72 is the product of 36 and 2. So 9 comes out as 3, 36 comes out as 6. So 7 square root of 2 minus 8 times 3 square root of 2 plus 4 times 6 square root of 2. So notice this is 7, negative 24, positive 24. So they add up. 7, you can think of it as 7x minus 24x plus 24x, it's 7x. So 7 square root of 2, because these two cancel each other. Again, you can go with the method that is discussed here or the method that I showed you, okay? 98, you can prime factor it, or you may recognize it as 49 times 2. X cubed is x squared times x times 1. This doesn't change. 32 is 16 times 2. And so the reason we cut them in this format, because we know 49 comes out as 7, x squared. So this goes out as 7. This goes out as x. This goes out as 4, and everything else remains. So take a look. 49 becomes 7, x squared becomes x, 2xy remains. 3x is outside, 4 joins it, 2xy remains. And so this is 7x squared of 2xy. This is 12x 2xy. And now notice this part is identical to this part. You can say, for example, 7z plus 12z is 19z. So 19x squared of 2xy. So I hope it's clear to everybody. It's very straightforward. Rather, just do the foiling. Multiply these two, square root of 2 times square root of 8, square root of 2 times negative 5 or negative square root of 2 times 5, 3 times square root of 8, and 3 times negative 5. These two square root of 16, this one minus 5 square root of 2, plus 3 square root of 8. Now square root of 8 Square root of 8 is square root of 4 times 2 is 2 square root of 2 and minus 50. So obviously, this is 4 minus 5 square root of 2 plus 6 square root of 2. 4 and negative 15, negative 11, negative 5 square root of 2 plus 6 square root of 2 is square root of 2. And we are done. What about this one? Let's remind you of the easy way out. A minus B, its conjugate is A plus B. Their product is A squared minus B squared. You can do the foiling, but you don't have to because this is A minus B, this is A plus B. So it's A squared minus B squared, which is 7 minus 10, which makes it negative 3. If they say simplify, divide, or rationalize denominators, means the same thing. In a case like this, you have to multiply and divide by square root of 3 over 3. Obviously, the top is 4 square root of 3. The bottoms, just 3. What happens when you have cube root? Well, remember, and of course, denominator can't be 0. Remember, the idea is that you want to put cube root of something so this comes out. Notice the exponent for this is 1. And what you want to do, you want to match it with this because if it's the same, it comes out. So how do you match it with this? You can't say I'm going to multiply by cube root of x. Rather, you have to multiply by cube root of x squared. Of course, you multiply and divide. Okay, so notice this one, everybody, has exponent 1. And with this one, they add up to 3. And it becomes cube root of x cubed, and it comes out. So it's important to make the exponent and the index identical for it to come out. So the final answer is 2 cube root of x squared over x. And what about this one? If they say rationalize, divide, or simplify the denominator, you have to multiply by the conjugate of the denominator. And remember, the conjugate of a minus b is a plus b, which makes it a squared minus b squared. So it's 1 plus square root of 2. You multiply and divide by it. So what happens, as I mentioned before, the denominator becomes 1 squared minus square root of 2 squared, or 1 minus 2, and the numerator is simply 1 plus square root of 2. This is negative 1, which changes the sign of everything in the numerator, and it becomes negative 1 minus square root of 2.